Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll find complex or imaginary roots of a quadratic equation. As per the problem, find the roots of the equation. We are given the equation x squared plus 7x plus 13 equals 0. This is a quadratic equation because the highest power on the x is 2. We have to find the roots of this equation. We can find the roots by solving this equation. We can solve a quadratic equation by either factoring it or using quadratic formula. This equation cannot be factored, so we have to use quadratic formula to solve this equation to find its roots. The quadratic formula is x equals minus b plus minus b squared minus 4ac over 2a. We use x in the quadratic formula because that's the variable in the given equation. A, b and c are the coefficients of the terms in the equation in standard form. A is the coefficient of the x square term. In the given equation, the coefficient of x square is 1. There is an invisible 1 with x square. So A is equal to 1. B is the coefficient of the x term. So B is equal to 7. And C is the constant term. So C is equal to 13. We can use these values of A, B and C in the quadratic formula. I get negative 7 plus minus 7 squared 4 times 1 times 13 over 2 times 1. Now we can simplify the expression under the square root. 7 square is equal to 49. 4 times 1 times 13 is equal to 52. 2 times 1 is 2. Next we can subtract the terms under the square root. 49 minus 52 is equal to negative 3. Square root of a negative number is not a real number. So that tells us that this equation has imaginary or complex roots. We have to use the imaginary unit I to write the roots of this equation. We can break up negative 3 as 3 times negative 1 under the square root. As you may know, I square is equal to negative 1. So in order to find the complex or the imaginary roots of this equation, we should replace negative 1 with I squared. The square root of I squared is equal to just I. These are the two complex or imaginary roots of this equation. We can write them separately as negative 7 plus square root 3i over 2, and the other root is negative 7 minus square root 3i over 2. The I is outside the square root because we did square root of I square, which is equal to just I. This should be the final answer for this problem. So these are the steps you have to keep in mind to find complex or imaginary roots of a quadratic equation. I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.